Hey, I'm going to do a quick introduction to a couple of online graphing programs that I think are great and that you can use in my class. The first is nplot. It can be found at noragulfa.com, nplot.html. I'll put links to these on the It's Learning class homepage. I'm going to plot some data real quick. When we graph, we have X on the horizontal axis, Y on the vertical axis, and this program allows us to put in labels. The data I'm going to put in are it's a distance versus time graph. Distance versus time means distance on the y-axis, and the units for that will be meters, and time on the x-axis, seconds. And then I'm going to put in some data. I wrote some down. I'm going to put in 0, 0. And then I'm going to put in 1, 5, 2, and 9.5, 3 and 16, 4 and 19, 5 and 27. Oops, 2. I thought, why is my graph looking wonky? Should be a 0.5. And then, yes, that looks way better. And then 6 and 30. So, as we look at the data, it's not quite a straight line, but that's the trend. And so, when we graph, things aren't perfect. It's not math. They're not going to follow a perfect function. And so we do a best fit line. These programs do it really, really well. This looks linear. So I'm going to try a linear best fit line, and sure enough, there's some points above it and some points below it, but that kind of represents the average of our data. It is not exactly proportional. It's certainly not squared. It's not an inverse square, or an inverse square. So linear fits our data. Here's the equation. If it's y equals mx plus b, or ax, a being the slope, here's our slope, and there's our y-intercept. And so we could write an equation for that line. If we want to save the graph, we put in d versus t. And I like this one because it saves it actually on your device. And so you can find it and pull it up. So if you want to recall your graph, here's that graph. So you can save them, and then you can recall them. You can pull graphs up. So you could graph this, and if you're turning in a lab, you might do a screenshot, or if you have a snipping tool, you might do a snip of the data table and put that in your graph, and then do a snip of the graph itself and put that in your lab. Did I say put that in your graph? I meant put that in your lab. So you would need to title this. This is the only thing I do not like about this program, is it doesn't put a title on your graph, and you have to have some kind of title up here. Distance versus time would be the title of this graph. So make sure if you use this program you put in a title. Sometimes your graphs are not going to be linear. They may be inverse. We get quite a few inverse and inverse square graphs in physics, and I plotted this one just so you could see. Do you see how this as y decreases, x increases? That's an inverse relationship. And so if we wanted to put a trend line, that would be the one. Maybe it's an inverse square. We can try that. No, that doesn't fit. So it's an inverse relationship. Again, it has units. This would be a people versus time. The more people doing a job, the less time it takes. So as people gets big, the time gets small. As time gets big, the people get small. I put units in. You have to have your axes labeled. And again, if I were to use this graph, I would have to write in a title or type it in, or somehow insert a title on that graph. Another graphing program I like is from the physicsaviary.com. Again, I'll put a link there, and it's called QuickGraph. And I think the reason I like this the most is it puts a title on your graph. So if I'm going to label the X stuff, I'm going to do that distance versus time graph. So I put time here. And let me take that X out. And on the y-axis, I have distance. Now this one does not put the units in. It doesn't have a different place, so you're going to have to put in meters for your distance, and seconds for your time or whatever. And I'll put a few points in, and then we'll end this. So if I go, we'll put a 1 here and a 5 here. I'm going to use the same graph I did before. 2 and 9.5 and 3 and 16. I'm going to skip a couple points, 27 and 6 and 30. Okay, so again, it's linear. It was linear last time. Here you have to choose. You're going to do a curve fit. So you do there, and you choose from a picture. It looks like this. So I'm going to choose that, and ta-da, there's our line. And you see up here in the corner, there's the equation of our line. The slope is 5. The y-intercept is negative 0.19. The only thing I don't like about this one is that you can save the graph, but it gives you a link. And so you'll need to keep a notebook or something of what the URLs for the saved graphs were. I like the presentation here. I like that it's simple. You can do a screenshot of the whole thing. You can do a snip of the whole thing. You're going to need data and the graph when you turn it in. You know, choose the one that you like. You're going to have to write a title in the other, but the other one saves stuff on your device. Here, the title gets put in for you, but it saves it as a URL. Maybe you like that better. But those are the two graphing programs that I like for use in my courses. Ms. Kavanaugh likes to use Google Sheets, and she has a video that I will link to for how to make graphs using Google Sheets. Thank you so much.